Scientific Inference and the Rationality of Inferring God's Existence. In the realm of science and philosophy, the processes of inference play a crucial role in how we come to understand the world and draw conclusions based on evidence. Inference allows us to bridge the gap between observations and theories, forming reasoned judgments about how the world works. Whether we are reasoning about natural phenomena, scientific laws, or ultimate questions such as the existence of God, the methods of reasoning we employ, deductive, inductive, and abductive reasoning, are foundational. Here, we will clarify the differences between these types of reasoning, explore the tentative nature of scientific theories, understand the role of paradigm shifts, and recognize the limits of certainty in science. With these principles in mind, I will argue that it is completely valid to infer the existence of God using the same rational methods that we apply in scientific inquiry. 1. Clarification of inference types: deductive, inductive, and abductive reasoning. In science and philosophy, we distinguish between three primary types of reasoning: deductive, inductive, and abductive. Each plays a different role in the process of inference and supports different kinds of conclusions. Deductive reasoning. Deductive reasoning is the process by which we arrive at a conclusion that follows necessarily from a set of premises. If the premises are true, and the logic is valid, the conclusion must also be true. Example. Premise 1. All humans are mortal. Premise 2. Socrates is a human. Conclusion. Therefore, Socrates is mortal. Deductive reasoning provides certainty when the premises are true and the logical structure is valid. In mathematics and formal logic, deduction is the primary method used because it guarantees a valid conclusion based on known principles. However, in scientific inquiry, deduction is often used in conjunction with other forms of reasoning. Inductive reasoning. Inductive reasoning involves drawing general conclusions based on specific observations. Unlike deduction, the conclusion in inductive reasoning is not guaranteed to be true but is instead probabilistic. It is supported by the evidence but could be revised with new data. Example. Premise. Every swan I have observed is white. Conclusion. Therefore, all swans are probably white. In scientific practice, induction is widely used to develop theories and laws based on patterns in empirical data. However, the limitation of induction is that no matter how many observations we make, we cannot guarantee that future observations will conform to the same pattern. Theories derived from inductive reasoning are thus tentative and subject to revision if new evidence arises. Abductive reasoning. Abductive reasoning, or inference to the best explanation, is the process of arriving at the most plausible explanation for a set of observations. It differs from deduction and induction in that it seeks to explain why something is the case, often using limited data. Example. Observation. There are wet streets outside. Inference. The most likely explanation is that it rained recently. Abduction is commonly used in scientific reasoning when forming hypotheses. It allows scientists to propose explanations that can be tested and refined. Abductive reasoning is crucial when we are confronted with complex or incomplete data, as we often are in science and philosophy, because it allows us to make reasonable inferences even in the absence of complete certainty. 2. The tentative nature of scientific theories. Scientific theories are not considered absolutely true in the sense that they are fully and finally verified. Instead, scientific knowledge is provisional. It is based on the best available evidence at the time but remains open to revision as new data or better explanations emerge. Predictive success and falsifiability. A theory is considered robust when it is able to make accurate predictions about future observations. However, as philosopher Karl Popper argued, scientific theories must also be falsifiable. That is, they must make predictions that could, in principle, be proven wrong by empirical evidence. If a theory is resistant to falsification and consistently makes successful predictions, it is provisionally accepted. However, this acceptance is always tentative because future observations could challenge or overturn the theory. For example, Newton's theory of gravity was incredibly successful in explaining the motions of objects on Earth and in space. Yet it was later refined and superseded by Einstein's theory of relativity when new data revealed limitations in Newton's theory, particularly at high speeds and strong gravitational fields. 3. The role of paradigm shifts. Sometimes, scientific progress is not a matter of merely adjusting existing theories but involves a paradigm shift, a fundamental change in the overarching framework through which scientists understand the world. This concept was introduced by philosopher Thomas Kuhn in his work, The Structure of Scientific Revolutions. What is a paradigm shift? A paradigm shift occurs when a dominant theory or framework is replaced by an entirely new way of thinking. This shift often happens when anomalies, data that cannot be explained by the current theory, accumulate to the point where the existing framework is no longer tenable. When a new theory emerges that better explains the evidence, it replaces the old one. Example: the shift from geocentrism, the belief that the Earth is the center of the universe, to heliocentrism, the sun-centered model, was a paradigm shift in astronomy. It radically changed how scientists understood the cosmos and required abandoning deeply entrenched ideas. Paradigm shifts illustrate that scientific theories are not immune to overhaul, especially when new evidence demands a more comprehensive explanation. 4. The limits of certainty in science. Because scientific reasoning is often based on inductive and abductive inference, absolute certainty is rare in scientific inquiry. Instead of seeking certainty, science aims to provide the best provisional explanations based on the available evidence. These explanations are always subject to revision if new data or better theories arise. Provisional knowledge. Understanding the limits of certainty is key to appreciating the scientific method. We do not claim absolute certainty in most areas of science, but we can be highly confident in theories that have withstood rigorous testing and falsification. For instance, we are highly confident in the theory of evolution and general relativity, but these remain open to revision if new evidence arises that challenges them. 5. Inferring the existence of God using the same reasoning. Given the principles of deductive, inductive, and abductive reasoning, it is entirely valid to infer the existence of God using the same rational methods we apply in scientific inquiry. Let's examine how. Deductive reasoning and God's existence. One well-known deductive argument for God's existence is the Kalam cosmological argument. 1. Everything that begins to exist has a cause. 2. The universe began to exist. 3. Therefore, the universe has a cause. If the premises of this argument are true, the conclusion necessarily follows. The cause of the universe must be transcendent, eternal, and powerful, which aligns with the attributes of God. This is a deductive inference based on rational premises. Inductive reasoning and God's existence. Inductive reasoning can also support belief in God. Consider the fine-tuning of the universe. 1. The constants and laws of physics appear fine-tuned for the existence of life. 2. Inductively, the best explanation for this fine-tuning is design rather than chance, since the probability of a life-permitting universe emerging by chance is astronomically low. While this reasoning does not guarantee the conclusion, as is the case with all inductive reasoning, it strongly supports the inference of an intelligent designer. Abductive reasoning and God's existence. Finally, abductive reasoning, or inference to the best explanation, is one of the strongest methods for inferring God's existence. Abduction is used to explain complex data by positing the most plausible cause. Cosmological data, the fine-tuning of the universe, the existence of consciousness, and objective moral values are all best explained by the existence of a transcendent, personal God. Theistic belief provides a coherent explanation for these features of reality that materialistic naturalism struggles to explain. Abductive reasoning, therefore, allows us to conclude that God's existence is the best explanation for the wide range of evidence available, including cosmology, morality, and the nature of consciousness. Conclusion. A rational inference to God. Based on the reasoning methods outlined, deductive, inductive, and abductive, it is entirely rational and scientifically informed to infer the existence of God. Just as scientific theories are tentatively accepted based on their ability to explain and predict phenomena, belief in God can be rationally inferred as the best explanation for the existence, order, and complexity of the universe. While scientific knowledge is provisional and open to revision, the inference to God is supported by strong philosophical reasoning and empirical evidence. Far from being irrational, belief in God is consistent with the methods of reasoning that underpin science and philosophy. Thanks for watching. Please like, share and subscribe, and comment below if you agree or would like to add your thoughts. If you would like me to respond to your comment, please make a level 1 comment directly below the video. I will respond to all polite level 1 comments even if it takes me a while, due to other commitments.